Hello everyone. In this video we are going to talk about mold design in SolidWorks. So let's say you have this part that you want to manufacture and you want to manufacturing using molds, whether it's casting using molds or injection molding or any other method that needs mold, because you are doing large scale manufacturing and you want homogeneous parts in terms of properties. You want isotropic parts because with 3D printing you cannot achieve that. You want a smoother part, faster production, cheaper, of course a bigger upfront cost. So if you want to design a mold for a part like this, how would you do it? So here I have made the part in SolidWorks. Right, this is EEE, which stands for my new name of the channel, Engineering Educator Academy. If you go to my channel, you see that I have changed the name of the channel a little bit. I added one extra word to it, Academy, because now with covering all of these courses that you see, that's my goal, is to cover all of these courses by the end of next year and probably a few more. You can basically come here and have almost up to 70-80%, or for mechanical aerospace, I would say, especially mechanical, you would have more than 80-90% of your major related courses here. So that would be fair to call this an academy here, not just any YouTube channel. So if I go back here and I want to explain how I make these two mold pieces, right? The two parts for it, so that you can do molding. So here, this is the part. I go to mold tools. If it's not available, if you don't see it among these top tabs, you always right click, go to tabs, and make sure you check mark that so now it's available. The first thing that really matters in molding is draft and draft angle, because if you make the walls of these parts perfectly straight, then when you try to get this part out of these two parts of the mold, it's not going to be easy. There is no angle between them, and the parts are just flush with each other and at 90 degrees, or with respect to the horizontal plane, no draft angle. So taking the part out of the mold is not going to be a trivial task, right? Because again, let's say this is the wall of the mold, right? And then here you have the molded part like this. And again, if there is no draft angle here in this area of contact, you're going to have a lot of friction. And it's not easy to take it apart, and especially if your molded part has thin walls, when you're trying to pull it out, there is a good chance that you break it or damage it. So one of the common things that they do in mold design is at the walls of contact, they try to give it a draft angle, some tilt like this. Now this is exaggerated. You of course never gonna have that much of draft angle unless specific scenarios come. And then here they try to, as I said, make some draft angle. So here, if you try to pull this part out, it's not going to be so hard, right? Because only a portion of that friction is going to stop you really from motion, and you are trying to help the part easily come out of the mold. So this draft angle here is something that they typically do, but as I said, it's not as exaggerated as this. Typically it's only 1 degree or 2, or maybe at most 3 degrees. So you don't want to, if the part has to be straight, relatively straight, you don't want to completely give it a big draft. So here, that's what we use. We try to use like 1 or 2 degrees draft angle and not make it like super tilted. So at this moment, if you look at my parts, what I have is a extrude here, this basically cylinder with the fillets, and then I have this extra extrude that is like for a stamp or something. And the first thing you want to do in the mold design, you click on draft analysis. And then it says, what is the direction of the pool? You choose the surface, the normal to the surface is going to be the direction of the pool. And then it tells you that, hey, there are some parts with positive draft, there are some parts with negative draft, and some parts that require draft. They don't have any draft angle. So if the part is completely divided between positive and negative draft, that's a good thing. Because especially, and all of the positives are on one side and all of the negatives are on the other side, then the line or the curve that separates that green region from the red region, that can be where the two parts of the mold are going to meet each other, right? So here, basically, as I said, this curve is going to fall right onto basically this plane and this plane, right? So that's exactly where you break the part into two pieces in terms of molds. Of course, the part is going to be in one piece when you mold it, but that's going to be exactly the separation plane of the two parts of the mold. If one part of it is entirely positive draft and one part of that curve here is entirely negative. But if there is a mix, like on the top of the green, you also have some red, that's not a good thing. You have to change the draft angle. And if there are areas that are like zero draft and you show them in yellow, then you need to apply a draft to them. Now, what draft? Definitely here, since the parts below this yellow are green, right? Okay, then you need to make sure that the draft that you give to the yellow area, which is this extrude on the top, EEA, is the same as the green area, not the same as the red area. Let me show you from the side. You can see from the side, it is not easy, super easy to see, but there is a small outward draft here, and that is only 1 degree. I can show you in the extrude here, right? It's an outward draft of 1 degree. So as the extrude goes up, the cross section gets slightly bigger. It's just 1 degree until you get to this curvature here, to this fillet. And then, of course, the direction of fillet is opposite here. So if you want, you definitely make sure the draft that you give to this bus extrude on the top has to be inward, not outward. So this bus extrude, when you go and look at the definition, right here, there is no draft. But if I want to apply, I click on it and definitely make sure that the draft is inward and not outward. So here, you see, if I make it more, you probably can see the effect of the draft a lot better, right? So if I make it like 10 degrees or 13 degrees, you clearly see it is shrinking inside as it goes up. But as I said, we typically go with 1 or 2 degrees, but definitely you don't want outward, you want it inward to match this fillet. Okay, so here I draft it for 1 degree inward, right? Or I can click on this draft command here and draft it, right? And now that it is good, I click on draft analysis again. I say, hey, this is the direction of the pool. And now you see the top portion is all green above this curve. The bottom portion is all red. So now I can basically break the overall mold for this into 2 pieces and make sure this curve is on that separation plane of the 2 pieces of the mold, 2 pieces of the mold. Okay, so I'm good. And here also it compares your draft against a threshold, 1 degrees. If you wanted to say, I want a 3 degree draft, then it gives you, say, hey, this is not 3 degrees. This is not 3 degrees, so you have to draft it further. But no, if all you want is just 1 degree, then you are good to go. So it depends on basically how much of draft angle you want to give it. But let's say I'm good with 1 degree right now. I don't want really the walls to be significantly drafted. Now, the next thing you need to do is to basically create the 2 parts of the mold. And before that, you need to create here this disc that you can see. This disc is a separating plane. So first you create that, and to create that, what you need is first this curve that I told you. The curve that above which you have 1 draft below which you have another draft. So first you determine that curve. You say that curve is separating the two pieces for me. And then you pass a plane through that curve, and that's called a partition or a separating plane. And then you can create the blocks of the mold and then use that partition plane to break it into two parts. Not only it does that, it also creates all of the cut extrude that you need on the mold to create it. Okay, so now we go here on creating the curve, which you can use the parting line or you can use the split line. So here I use the parting line. It says what's the direction of the pool. Again, I choose this face normal to that is the direction of the pool. And then I look at the draft analysis. So it tells me which area or what kind of draft. Then I choose this guy. It says split faces, and then for parting line I choose this curve that separates the two areas, the green and the red, and I OK that. And now it's created the parting line, and it kind of shows you with different shadings the areas that are a little bit different in terms of drafting, right? Might not be super clear. It will be clear when I create the surface. So I choose a parting surface. Now that I have the curve, it says, what is your parting line? I said the one that I just created. And then it says, okay, now how do you want to create the surface? So the surface is a plane that is coplanar with this curve. And it says, how far do you want to extend it? Let's say 15 mil from each side of this arc, but not inside it, outside. So I click on reverse direction, and guess what? It extends this disc, this planar disc for me, which is the partition surface. So now, as you can see, the partition surface separates the areas with positive and negative draft angles. So now that I have this, all I need to do is now to go to tooling split and create the top and the bottom part of the mold, and then they are going to be broken or separated by this disc. So now I click on tooling split. It says, okay, now you need a plane or a planar face, and you need to draw the sketch for the shape of the mold, because not always the shape of the top and the bottom part of the mold are like cube, right? So the sketch of them is just a square or something. Not always. You might design your mold to be any different shape, but for simplicity here, we stick to that square thing. So here we go with this plane, we see normal to it, and then we are going to draw a square containing the circle. And now if I get out and look in 3D, you see it has already created the cubes for me. And then I can change the depth of the cubes, right? So I can make them as tall as I want in either direction, right? Let me just or you might want to make one of them taller than the other, so it's all up to you. Let's make the bottom one 10 and the top one 20, and I'll tell you why. So, and then you say, okay, and guess what? Now you have the top and the bottom part of the mold. What you might want to do is you can hide this parting surface here if you don't need it, and this parting line here, let's hide that as well. So now you have three solid objects under the solid body folder. You have three of them. One of them is the object itself, and the two of them are the tooling split 1 and 2, right? These are the top and bottom part of the mold. If you want to see better through them, you can make any of these transparent. So you right click on them, then go to appearance, and then go under advanced elimination, and then change the transparency to any level that you want, right? So now you clearly can see through the top part, and now let me make also the bottom part transparent for you so you can see through it. And there we go. Now not only you can see the parts, you can see the top and bottom part of the mold. If you want, you can hide the part itself. So now if you can see, This here is, this is really the cavity. These are the cut extrudes. There is no solid object there, right? If I just hide one of them, you can see it much better. Look here. So this is, and I also need to hide the object itself too. So let me hide the object for you. Here, and the whole thing is hidden now. So look now, you clearly see this is the bottom part, right? You clearly see it is the cavity, right? Now you might want to get rid of the transparency. Maybe now you can see it better without the transparency here. So let me get rid of the transparency for you here. Right, so now you clearly can see, hey, right, this is the top part. Then you can do the same thing for the bottom part here, right? This is the bottom part. Again, you clearly can see it is the cavity in it, and now I can go ahead and use them for any application like injection molding or casting or anything that needs mold. So here we go. These are the two pieces. And now that I got my two pieces, the molding part is done, but now you know in real life what you need to do is to create some guides and some holes on the two pieces that go together and keep them in position. And you also need a nozzle, right, on the top part, so you can pour the molten plastic or anything molten metal into the mold. If there are several parts, you also need the sprue and the runners, and there are so many other things. If it is for injection molding, then on one of these pieces, typically the bottom piece here, you also need to have the areas for the basically ejector member, and there are so many other details that you need to add. So these are just mostly really the cavities. Now, if you want to do all of those further processing, you can go ahead and save these parts separately, the top part and the bottom part, and then do any processing that you want to them. So here, I right click on the solid bodies and say save bodies, and then I say I want both the top and the bottom part to be saved for me, and I say OK, and now it is going to give them some name and save them as separate objects. And once I have these separate objects, I can process them also separately. So let me get the parts here. So now you see this is one of them, correct? And then this is the other one. And so now that I have these, right, in the bottom part, I go ahead and create my guide. So I go here, and then I create 4 circles, right? So I go at a specific location and give it some diameter, let's say 3 mils in this case, and then I put it at a specific location. Let's say this 13 is okay for now, and then also this horizontal one, also 13. And now what I need to do is to basically mirror that, right? So I can choose this guy and then mirror it with respect to this axis to get here, and then I also need another mirror, or I can use a pattern. If I remember my dimensions from the original part, then I can use a linear pattern. So it's completely up to you here. I did not give it a specific dimensions for these guys when I did the sketch for them, so I would rather use mirror to make sure I have perfect symmetry here. So here we go, that's my sketch. And then I go to features and then create the guides. Remember the height of the top part was 20. So if I want, I can make this go entirely through that part, or maybe just 15 right now, something like this, right? So now this is my bottom part with the shafts or with the guides. let me go ahead and save that. And at the same time, I go to the other one, and on here on this surface, I am going to repeat the very same thing for you. So again, this is going to be 3 and 13, 13. Mirror that, and then I will create the holes for the shafts. And you have to also consider some tolerances here, because if this is 3 and that is 3, then they are not going to easily move inside each other. So what you need here is either a clearance fit or a transition. Definitely it's better to have a clearance fit so they can move within each other, but it should be quite tight clearance, not a very loose one, so they can hold their position relatively well. If I want to 3D print this, because you know these days they are trying to, and it's one of the topics I mentioned in one of my videos, new trends in 3D printing, they are trying to 3D print molds for plastic manufacturing and molding, but this molds are going to be made from heat-resistant resins that have a lot higher melting temperature than, let's say, PLA. So you might want to 3D print this. Then, depending on the diameter of the nozzle, let's say if it's 0.4 mil nozzle, right, then the closest number you can get to 3 is 3.4. Then you might just go with 3.4, which is like one layer missing, right? And then that kind of guarantees for you that the shafts are easily moving inside these holes. Okay, so again, it all depends on how you are going to manufacture the mold. Is it a CNC, is it a 3D printer, or what? And what is the resolution of that machine in the X and Y direction? So here, as I said, I'm going to create these 4 holes, and then once I'm done, it is going to be simple assembly if you want to see what's going on. So let me just create these. Remember, I raised those shafts for 15 mils. So now I'm creating these cut extrudes for 15 or maybe 15.2. Let's say, again, it's a 3D printer. I consider 1 extra layer. So the shafts are completely inside the holes and there is no room for them to have any gap between these. So this one can perfectly sit on the bottom one without any chance of, again, the shaft is longer than the hole and a little bit just because of manufacturing errors, and then there will be some gap. So I make the holes a little bit longer than the shafts. And now that this is ready and the other one is ready, if you want, I can show you in an assembly, right? That's what my mold is gonna look like. One other thing that I guess I just forgot to do is the in the top part, I forgot to add the nozzle, because you have to have a way to bring in the plastic, right? So I go here, and then I create a nozzle. Now, of course, you want to make sure it is not like super big. So maybe this, I make it like 2 mils. And then I will do a cut extrude with the draft angle, right? And then I just go down for maybe 5 mils and a little bit, let's say 3 degrees, or let me reduce this, go down to 2 mils maybe, right? And bring this guy down to maybe like 15 degrees or so. So it is gonna be like a countersunk hole. And then here I go on this surface, I choose this guy as my sketch with convert entity, and then cut it all the way through. And guess what? Now I have the nozzle, which is coming through here. And that's another thing that you have to consider very carefully, that the bottom of your nozzle should not pass through any of these cut extrudes. If it does, that's absolutely not a good idea. Okay, although it's better to put it toward the center so the spread of the plastic is kind of more uniform, but if the bottom of the nozzle it is intersecting with your patterns of the mold, it is gonna ruin your mold. So you make sure definitely to move the location, right? So here I have to go and move the location of it to a separate place, right? So for that, I put this in the transparent mode so I know where I'm putting the circle. So let me get rid of this concentricity that I have here. So I can move it to anywhere I want if I just allows me to get rid of this concentricity. If it doesn't, that's fine. I go ahead and maybe make it somewhere here, right? So remember again, this guy ought to be like 2 mils, right? And so now you see it gave me an error, and the reason is because of this convert entity that I did. So it has to be this one now, and that should go through, right? And guess what? Now the location of the nozzle is not going to cause any problem for the top part of the mold. So now this is good to go. And let me just put a complete different color than gray on this one, right? And so now if I go to assembly, I can bring these two parts and put them next to each other, and you can see the two parts of my mold. So here we go. You can insert your components. This is one. And then you can bring the other one. Like this. And now all you need to do is to have, let's say, this one and this one to be concentric, like what I showed you. And then to make sure, again, everything is in good condition, I make those two also concentric. So now it should be good to go. I assume you can add one more, although you have to make sure it's not redundant. So this is another one. If I use two of the guides, by the way that I did it, this one is really redundant. So let me get rid of that. And then you can also make these two to be coincident, right? Flush, like this. Sitting, and there we go. Now I got my mold, and if you want here, instead of coincidence, I can go ahead and change it to parallel for you, so I can move them up and down so you can see. So now, as you can see, right, this guy comes and sits right on it, and when they sit right on the top of each other, there should be still some gap between them, right? So let me show you from the side. You see, the guides are sitting easily inside the holes because they are a little bit bigger in diameter and a little bit taller. This is the nozzle, comes in, fills this area with plastic, and then you can do your injection molding. So hopefully this video was useful to you, and I will see you in my next lecture. Thank you.